This is Lab 5, and this lab is about repetition and voting. In this lab, we implement an error-correcting code to not only detect, but this time correct errors. So we need to write VoteOn.c, and in order to start, we need to think about what the function that we have in the VoteOn.h file will do. We know that the function is supposed to determine if a majority of items in the list are identical. So if it's identical, it returns the index of one of the majority items, like the first one found. If not, it returns -1 to signal a failure. So the algorithm to solve this problem is to have a nested for loop that goes through the list and looks for one with the most repeats. So here we know for loops, we can declare variable integers I and j, and we need variables for the maximum for our particular item, which is what we called max repeats. So this stores the number of repeats of the majority item. So if we find more repeats than that, it will become the majority item. We also need the index of max, which we call max index. And this is the index of the item in the majority. We want the max repeats for a particular case as well. So we also need number of repeats for the current item, which is I in the for loop. So what else we do is set the max index to -1 because this is the fail condition. The fail condition is assuming that there isn't enough in the majority. We can also set max repeats and current repeats to 0 because we need to assume first that nothing has been repeated yet. So because our algorithm is a nested for loop, we know how to set that up. I counter is for the outside for loop and j is for the inside for loop of the nested loop. We make I and j less than n instances, which is the number of instances. We do less than n instances because we compare up until the last item in the list. What we need to do is make a comparison between what we see at I and what we see at j, and the memory that happens because it's a void pointer. So we can perform an if statement and use memcomp. So memcomp will return 0 if instances at I and j are the same. And if that's the case, we know that we can add to the total of repeats, which is just what we do here. So current repeats ++. Here we are incrementing every time it's the same at I and j. So basically, it just goes through the instances and looks for repetition and adds to the total. So now that we have the number of repetitions, we now need to store the largest one. So we can have another if statement, and if the current repeats is greater than the max repeats, then what we need to do is simply make what was once the current repeats into the max repeats. And because max index and max repeats are linked, that also would mean the max index would be the position of where I is in the counter. So after doing all that, then we can return max index. So now we can run the code. So when we open up main.c, we can see what the results are and comparing them to what they should be. So voting on the big list returns 0, and when we look at list 1, we see that 5 out of the 8 are the same, so we should have returned 0, which is correct. For the short list, it returned 1, because 2 out of the 3 are the same, which is A and C are identical, which is right, so it should return 1. For the third list, all are different, which is -1. So voting on an even list returned 1, which is true because even numbers of elements or 2 are identical. A list with 2 identical pairs returns 0, which is also correct, and multiple elements returned 4, which is correct. And finally, voting on ints returns 0, and we look at the array of pointers, 2 of them are the same, so that's why it returned 0. So the function works, and that is Lab 5.